sets and set notations. This lesson is relevant for Cambridge O-levels, especially for grade 9s and 10s. When we learn about sets, we have to know the meaning of certain important words that we use in these lesson sets. First thing is, you have to know what an element of a set is. Look at this example. It says list the elements of the set V. So, the set V means the vowels in the English alphabet. So, this is how you list the elements of this set V. V is equal to open curl brackets A, E, I, O, U. So they are the vowels of the English alphabet, and you close the curl brackets. So each letter A, E, I, O, U is called as the element of this set V. We separate each element using a comma, and the word element can be symbolized as below. So we can say A is an element of set V. This is how you symbolize it in terms of sets. So it says E is an element of set V. I is an element of set V. Also we can say O is an element of set V and U is an element of set V. You can fill the two blanks over here. And if you could count, there are 5 elements. 1, 2, 3, 4, 5. There are 5 elements in this particular set V. So we can write the number of elements in set V. This is how you write it in terms of sets. Number of elements in set V is equal to 5. Let me continue with another example. It says list the elements of the set X. So we have to know what is this set X is. So the set X is the first 7 prime numbers. So in this case, you have to know the prime numbers. The first 7 prime numbers are 2, 3, 5, 7, 11, 13 and 17. So how could you list this word list? This is how you list it. You have to say X is equal to, you have to use curl brackets, and the elements are 2, 3, 5, 7, 11, 13 and 17. Each element is separated with a comma. So how could you say that 2 is an element of the set X? We can show it like this. 2 is an element of set X. So how do you show it's an element? This is the symbol we use to show that a given value is an element of the given set. Also, we can see that there are 7 prime numbers in this particular set. So we say the number of elements in set X, you show it like this. Number of elements in set X is equal to 7. What is important here is for you to know how to write what is said in English in terms of this set notations. So that then it makes you to do the sum easily. Okay, so this is another example. So you can try this. List the elements of the set E. So this set E means the even integers between 50 and 62 inclusive. You know the meaning of the word inclusive. So you have to include 50 and 62. So E equals to open curl brackets. We are going to list the elements, separating each element with a comma. 50, 52, 54, 56, 58, 60 and 62. So they are the even numbers between 50 and 62 inclusive, and you close the curly brackets. So you can call all these 50, 52, 54, 56, 58, 60 and 62 as elements of the set E. So it says to write the number of elements in set E. So we have, how many elements do you have here? You can count and say 1, 2, 3, 4, 5, 6 and 7. So the number of elements in set E is 7. You can do it of your own. So this is about the subsets. What is a subset? You can see that A is inside B. So everything in A is entirely inside B. We can say that A is a subset of B. Actually, the subset is a smaller set which entirely contained within another set. We can symbolize A is a subset of B. So this is the symbol that you use in sets to show that it is a subset. Now if I want to write B is a subset of A, this is how you do it. B is a subset of A. So in this case, B is inside A. Look at the figure. You can see that A is the big set, B is the smaller set. So B is entirely inside A. So I will explain about subset using an example. Look at this diagram. Can you see that the set A has 3 elements, 2, 3 and 4. And all these 3 elements are included in the set B, which is 1, 2, 3, 4 and 5. Also there is a main set called U, which has 1, 2, 3, 4, 5 and 6 as its elements. What I have done here is I have drawn set A inside set B and set B inside this main set U. So I can call set A is a subset of set B. How could I symbolize subset is this way. Set A is a subset of set B. The symbol that you use to represent a subset is this. Okay, look at this example as well. So you can see there is a set called X with elements 2, 3, 5, 7, 11, 13 and 17. And I have highlighted 3, 5 and 7, which these 3 elements are there in the set D. So I can clearly see that set D is a subset of set X because the smaller set D and the bigger set is X. Every element in the smaller set is there inside the bigger set. So I can symbolize it as D is a subset of X. So there are further examples. You can try and see. There is a set called B. So you have 3, 7, 11 and 17. So you can see that all the elements in set B is there in the set X. So I will call that set B is also a subset of set X. Look at P. So the elements of P is 13, 15 and 17. If you look at the set X, X does not have the value 15. So you can say that P is not a subset of set X because the element 15 is not there. So how do you show it? You can say P is not a subset of X. So K and J you can try and see. Okay, now I am going to explain you another set notation, another symbol. So this symbol is about the elements and not an element. So I think we learned about elements at the beginning of this lesson, but not an element is what I'm going to explain here more. So if you want to show it's an element, this is the symbol that you use to show it's an element. And if you're going to say that it's not an element, we have to use this symbol. Look at this. 6 is not an element of B. So if you take the set B, in set B you have the elements 4, 9, 2 and 7. And you can clearly see that 6 is not included in B. Therefore, you can say 6 is not an element of set B. Dog is not an element of A. So you just check and see the set A. In the set A, there's nothing called cats and dogs. It has A, B, C, D, E, F. So we can clearly see that dog is not an element of set A. There's a small exercise over here. So you can use the symbol to say whether it's an element or not an element. So you're going to check with the set C. You have to see whether the word lorry is there inside the set C. It's not. So you also have to check with the set F. The set F, it says the people in this room. So dog is not a person or people in the room. So again, dog is not an element of the set F. And they also look into the set A. In set A, you have A, B, C, D, E, F as the elements. And you can clearly see that E is included in set A. So E is an element of set A. Okay, now look at this. So these are the students who play soccer in a class. So Alex, Casey, Driv and Hunter. And these are the students who play tennis in a class. Casey, Driv and Jade. So we are going to put this information into a graphic which gives you much more clear information. So here what I do, those who play soccer, I have put them into the blue circle, and those who play tennis, I have put them into the yellow circle, and I have labeled it as soccer and tennis. But I can clearly see that these Casey and Driv, they play both the sports. So I can show that part as well. So what do I do when I show this information in a graphic? I will draw a Venn diagram. So this is the Venn diagram, and you can see that the two circles are overlapped in the Venn diagram. So this overlapped region I use to input the information of the common elements of both the sets. So here the soccer and tennis are the two sets. So Casey and Driv are the two players who play both soccer and tennis. So I have input that information right to the middle over here. And to the left of the circle I have put Alex and Hunter who play soccer only. And to the right of the circle I have put Jade who play tennis only. So this is the Venn diagram. So when you talk about sets, you have to know what is this union is. Union means those who play soccer or tennis. So in a union, you have to input all the information without repetition. So you can say that soccer union tennis. That means all those who play soccer or tennis. We have Alex, we have Casey, we have Driv, Hunter and Jade. So these are the 5 students who play soccer or tennis. But you can see that I have not repeat any of the elements in this set. So the number of elements in S union T, this is how you can write this in sets notations. It says the number of elements in set soccer or tennis is equal to 5. The next thing that you have to know is the intersection. So we learnt about the union in the previous slide. Now it is the intersection. Intersection means the common region, which refers to both the sets. In our case, if I follow the same example, those who play soccer and tennis, not soccer or tennis, here soccer and tennis. So Chelsea and Drew, they play soccer and tennis. So intersection is symbolized as this. Union to the other way around, it's like a U shape. So intersection is the other side of the union's symbol. So this is how I put it into the Venn diagram, the graphic. So I write the KC and Driv at the middle, the common region. And the number of elements in S intersection T is equal to 2. So you can see there are 2 elements in the intersection region. Well, look at this diagram. In this diagram, you can see to the left of the diagram, I have highlighted it in purple and I have input the 2 names Alex and Hunter. So here, Alex and Hunter, they play only soccer. And you have to be specific, they play only soccer. And to the right of the diagram, over here, you can input who plays only tennis. So Jade plays only tennis. Now, if I ask from you, who plays soccer? Then your answer should be Alex, Casey, Drew and Hunter, because you know all these 4, they play soccer. If I ask from you who play tennis, then your answer is Casey, Drew and Jade, because all these 3 players, they play tennis. But if I ask from you who play only soccer, that is this Alex and Hunter. And if I ask from you who plays only tennis, that is Jade. Also, if I ask from you who play soccer or tennis, it refers to the union. That is Alex, Casey, Drew, Hunter, Jade. So all 5, they play soccer or tennis. Also, if I ask from you, those who play both the games, soccer and tennis, that is Casey and Drew, which you write their names over here. This is those who play soccer and tennis both. So back again, union, it refers to all the elements. Intersection, it refers to the common elements. So union you can symbolize with a U shape, and the intersection you write the shape other way around. Look at this small exercise. You're given information about set A 1, 3, 5, 7, 9 and the set B 2, 3, 5, 7. So in the first question it asks from you A union B, that means all the elements in A or B. So you have to write down all the elements without repeating any element. In the second question, it asks about the intersection A intersection B. So it refers to the common elements of A and B. So just try to answer it. Your answer is A union B, all the elements of A or B, 1, 2, 3, 5, 7, 9. A intersection B, that means the common elements for set A and B, 3, 5 and 7. So it's clear. Nextly, we are going to talk about the universal set. A universal set for a particular problem is a set which contains all the elements of all the sets in the problem. And we can denote the universal set by the capital letter U or this Greek letter over here Z. Look at this. So I say that the universal set, which is U, is equal to few names I have given. It's Alex, Blair, Casey, Dave, Erin, Francis, Glenn, Hunter, Ira and Jade. So this is the universal set and it carries 10 elements. So I'm going to input all the information into a Venn diagram where the set S shows Alex, Hunter, Casey and Dave. Set T, Jade, Casey, Dave. Set V, Jade, Glenn and Dave. So I have 3 subsets of this particular universal set. So what do I do? The first thing here is, you can see the number of elements in set S, I have written it as 4. The number of elements in set T, you can write it as 3 over here. And the number of elements in set V, also 3. And if I am to input this information into this Venn diagram, Driv is common for all 3. So this is the region which shows the common area for all 3. And Casey is common for S and T only. That's over here, S and T only. And Jade over here for T and V only. Jade is common for T and V only. And you can see there are no names common to S and V. No names common to S and V only, because Driv for all 3. So here common for S and V only. So it's not there. Alex and Hunter is S only. Glenn is V only. And there's no name for T only over here. So we input all the information into the subset S, T and V. And if you exclude these names from the universal set, if you exclude Alex, and then we have Hunter, we have Casey, we have Driv, Jade and Glenn, you can see Blair, Erin, Francis and Ira are not included in any of the subsets S, T and V. So we have to write those names outside these 3 sets. But it is within the universal set. So all the elements of the universal set, you have to include it into the Venn diagram. Okay, so this is a small exercise we are going to do. So the universal set carries 2, 7, 8, 9, 15, 17, 19, 22, 24, 31, 39, 42, 45 and 50. And the set A carries 2, 7, 8, 15, 19, 24, 31 and 42. And set B carries 2, 8, 17, 19, 22, 39 and 45. So how are you going to input this information into the Venn diagram? First thing is, you have to fill the. So here I am going to start the question. This is the Venn diagram and I am going to input 2, 8 and 19. So you can see 2, 8 and 19. 2, 8 and 19 are the common elements for A and B. Then I am going to start filling the elements of A only. So the remaining elements, that is 7, 15, 24, 31 and 42, that is A only, and also B only, which is 17, 22, 39 and 45. Then you check and see whether you have input all the information of the universal set that is over here, and if there are any values which you have not input for this set A and set B, you have to write it somewhere outside A and B but within the universal set. Let us see. So 9 and 50 are the 2 elements which are not there in A and B, but that is there in the universal set. So you write it outside A and B. So this is one example how to fill a. Look at this example. The universal set has 2, 6, 7, 9, 10, 12, 27, 31, 32, 36, 37, 44 and 50. We have three subsets D, E and F. So D it's 2, 9, 27, 36, 44, 50. E 2, 9, 12, 31, 32, 50 and F 2, 9, 32, 37 and 44. So we are going to input all this information into the Venn diagram. We will first draw the universal set, and inside the universal set we will draw the three subsets as this. And the first thing is you have to find out the common value for all three D, E and F. So that we have 2 and 9. Then I have the element that is common for D and E only, which is 50. Also I have the element that is common for D and F, that is 44. D and F only, that is 44, and it is E and F only, which is 32. So if you could check with the set D, we have already input 2, 9, 44 and 50, but 36 is D only, also 27. So 27 and 36, it's D only. And we have 12 and 31, that is E only. Finally, we have 37 for F only. So if I could check and see whether I have input all the information correctly, set D 2, 9, 27, 36, 44 and 50. Set E 2, 9, 12, 31, 32 and 50. Set F 2, 9, 32, 37 and 44. So if you could look into each individual set, you have input all the information. Then you are going to check whether there are any elements which are not there in D, E and F, but it is there in universal set. So if you could check it clearly, 2 and 6, it's not there in any of these three sets, as well as 7 and 10 is also not there in these three sets. So this is how you input information into a Venn diagram.